Hello everyone, welcome to another video. In this video, what we're going to focus on is the CSEC paper 2, and the section of it that we are focusing on is the unit of measurement geometry and trigonometry. And what we're going to do in this video is to solve a series of different questions that comes on various past paper over the years. If you're new to my channel, please remember to like, subscribe, and share. Let's begin. The diagram below, not drawn to scale, shows a circle, center O. The line BC is a tangent to the circle at B. Angle CBD equal 42 degrees and angle OBE equal 20 degrees, as you can see demonstrated here in the diagram. Calculate, giving a reason for each step of your answer, the measurement of angle BOE. So the first thing that we need to do is to identify angle BOE. So BOE is this angle here at the center. Now, how can we determine this angle based on the information that is given? We realize that angle BOE is in the triangle BOE, right? So let us make a sketch of that triangle right here, so we don't have too many lines to focus on. So this is O. Now at this point that's E, and at this point was B, and that was given as 20 degrees. We were asked to find this angle, so that's what we have there. Now what do we know? We know that OB is a radius, therefore this length is equal to this length. So therefore this length is also equal to this length, which means that this triangle is an isosceles triangle. So therefore these angles, the base angles, are going to equal, so this angle is going to be 20 degrees, right? We know that. So we could write it out to say that angle EBO is equal to angle BEO, which is equal to 20 degrees. And the reason for that would be isosceles triangle, right? So that's how we know. Isosceles triangle. You don't have to write out the word, right? So that's how we know that this angle is 20 degrees. But that's not the angle that they asked us to find. They asked us to find the angle at O here. So what can we use? We can use sum of angles in a triangle that equal to 180. So therefore, we can say that angle BOE is going to equal to 180 degrees minus the sum of the two angles that we know, which is 20 degrees plus 20 degrees. And the reason for this is going to be sum of angles in triangle, all right? So that's the reason there. Then we can work out this. So it's going to be 180 minus 40. All right. So 180 minus 40, that's going to give us 140 degrees. So we answer that and we'll get our 2 mark here. So this angle is equal to 140 degrees. All right, and you get a 2 mark for that. Now, to the next part, they ask us to find angle OED. So we need to find that angle OED. So OED, which is this piece right here. All right, so that's what we want to find there. Bear in mind that we know this angle, which is 20 degrees, because we worked that out, and also we know this angle, which is also 140 degrees. All right, so we could put that in our diagram to make it much easier. Now, when you look at this, we could use the alternate segment to determine that angle here. Now, what is the alternate segment? They give us this angle right here, which is 40 degrees, and that is angle DBC. Now, this is the segment that angle is in, right? Which means that there is an angle in this triangle, in this diagram, sorry, which is equal to this angle outside. Now, you can think of it as an opposite thing. So you're looking from here, and we draw a line like that. Which angle that gives us? That gives us this entire angle here. That entire angle that is formed in the triangle DEB. So that entire angle is going to have the same measure as this angle, right? So we could write a statement to work this one out. And what would say is that, would say that angle CBD, right, which is this angle here, right here, that one that was given, is going to equal to angle DEB, which is this one that I highlight here, right? DEB. So those two angles are equal, which is just therefore going to equal to 42 degrees. All right. And how do we know this? We write our reason. The reason for this would be angles in alternate segment, all right? So angles in alternate segment, all right? So that would be the reason for this one. Now, how can we know this now? Notice now that these two angles here, the angle that they asked us to find, which is angle OED, and the angle BEO, those two angles must sum to be 42 degrees. So we're seeing that this entire angle here has a measure of 42 degrees. Therefore, it's just a matter of subtracting to get the other one, right? So you can see that this angle here, angle OED, is therefore going to equal to 42 degrees minus 20 degrees, which is therefore going to give us 22 degrees, all right? So we'll get our 2 mark there. Then now they ask us for the third problem here, which is angle BFE. We need to identify that BFE, which is this angle here. That's the angle there, BFE. Now, how can we determine this angle? Now, before we can determine this angle here, we need to determine another angle, because we don't have enough information as it stands. So we would need to determine another angle. So based on the information that we have, what else could we determine so that that value will help us to determine this angle? Now, we could determine this angle up here, which is D, all right? And why is this so? Because when you look at it, if you, let me chase out a diagram here. If you chase out the edges of this, what you will get is a cyclic quadrilateral, right? And what we know about cyclic quadrilateral is that opposite angles in a cyclic quadrilateral sums to give 180 degrees. So if we can determine this angle here, it would be opposite to this one. And then we are able to determine the value. Now, the one at the center here, note that they share the same arc, which is BE, right? They both share that arc there. That means the one at the center is going to be twice the one at the circumference, right? So we could use that principle, right? So we could see then, we could see that angle EDB, which is this angle EDB, is going to equal to 140 degrees divided by 2, which will give us 70 degrees. And how do we know this? The reason for this would be angles at the center is 2 times the one at the circumference. All right, so that's the reason for that one. So we are saying that this angle now is 70. And then now we could use the idea now of the opposite angles in cyclic quadrilateral to determine this angle. So we know we're saying that angle BFE now is going to equal to 180 degrees minus 70 degrees, which is going to equal to 110 degrees, right? And the reason for this would be opposite angle in a cyclic quadrilateral. So the reason for this, how we know, is opposite angles in a cyclic quadrilateral, all right? All right. So opposite angle is in a cyclic quadrilateral, and you will get your 3 marks for that. Now to part B of the question, it says the diagram below, not drawn to scale, shows the position of 3 ports, P, Q, and R. As you can see the diagram here, here is point P, Q, and R. And it says Q is 80 kilometers from P. So see the distance from P to Q, that's 80 kilometers. And R is 100 kilometers from Q on a bearing of 66 degrees, right? So that's 100 kilometer. They didn't put the bearing on it, but we could put it because they tell us. So the bearing from this line to that line has a measure of 66 degrees. So that's what they're telling us there. And they are saying that angle PQR is 54 degrees. That is already there. And they are asking us to determine the bearing of P from Q. So they want us to determine the bearing of P from a point Q. Right? So these are the 2 points that we are interested in. We are interested in point P and point Q. They want us to determine the bearing. So the first thing that we focus on is the from. Which letter comes after the from? Q. That means that's exactly where the angle measurement should be taken from. It should be taken from point Q. But when we're talking about bearing, everything starts from north. So if we start from north, right, the bearing would be this angle all the way from north down to this point here, to the line that connects P and Q. And that's pretty straightforward, as you can see. So the bearing here is simply going to equal to 66 degrees plus 54 degrees. And that is going to give us 120 degrees. And we get our 2 marks for this part I. The next part says the distance PR correct to 2 decimal places. So we want the distance PR, which is this distance here. We want the distance PR, which is this distance here. All right, that's the distance we are interested in. So based on what we have, what's the easiest way to determine this? We have 2 sides and an angle between the 2 known sides. That means the easiest thing to use is going to be the cosine rule. So we can use the cosine rule to determine PR. So let's just remind ourselves what the cosine rule is. The cosine rule says A squared is equal to B squared plus C squared minus 2 times BC times cos A. All right. So what is this really saying? If the side that we want to find, we must know the angle that is opposite to the side that we wanted to find. So we want to find PR. So PR would be our A squared in this case. So we could put PR squared, all right? Is going to equal to B. We could let any one of the side be B if we want, but for consistency, let's say that this 100 here is B, and let's see where 80 is, that's C, right? So if you fill that out, it's going to be 100 squared plus 80 all squared minus 2 times 100 times 80 times the cos of the angle that is given, which is 54 in this case. All right. So from here, it's just a matter of using up your calculator to determine the value. So PR squared is going to equal to what's 100 squared plus 80 squared. That is just going to give us 16,400, right? Minus, and then you put all of this on the calculator. And when you put this on your calculator, your expected answer would work out to be 9,400 and 4.56. And then from here, you will just do a little bit of subtraction. So we know that PR all squared is going to equal to 16,400 minus 9,404.56. And that's going to leave us back with 6,995.44. And from here, we are not interested in PR squared, we are interested in PR. So we need to take the square root of both sides. So we're going to take the square root of this side and also take the square root of this side. So the square root will cancel out the square, so that leaves us back with PR, which is what we want to find. And then when we take the square root of this number, it's going to approximately give us 88.64 kilometer. So the distance of PR character to two decimal place is going to be 88.64 kilometer. All right. So we're finished with that one. Now we're asked to determine the measure of angle QPR to the nearest degree. So first we need to identify that angle QPR. So that's QPR, which is this angle here. That's the angle that we want to find. Now, these formula, note that the cosine formula is on the front page. It's in your booklet, you are given these formula. Now, what do we know here? We now know three sides and one angle about this triangle. We know that it is a non-right angle. And we're asked to find another angle. So the most suitable thing to use would be sine. So if we use sine, what do we know about sine? We know that A, right, which is the formula, let us remind ourselves, which is A over sine A, which is the angle, is equal to B over sine B, which is also equal to C over sine C. So how does this formula work? We must know the side opposite to the angle. So we want to find this angle at P, right? That's what we want to find. So if we want to find this angle at P, then we know the side that is opposite to it, which is 100. So we could see then that is going to be 100, right, over the sine of P. And let's use P for the angle, all right? The sine of P, that's what we want to find, is going to equal to, we know this side and we know this angle. So that's just going to equal to 88.64 over the sine of 54 degrees. So that's how it works. So you know that this angle is opposite to that side. So that's what we just did here with the formula. And we work out this side a while ago to be 88. So we're using this angle and that side. That's how the sine works. All right. The sine rule works, that is. Now, all we need to do is to just put this on our calculator and do a little bit of math. So we can keep this side as 100 over sine P. And then when we put this side and our calculator, our expected answer is going to be 109.57. Right? Correct to two decimal place. So from here now, we want to transpose so that sine P becomes the subject. So we can multiply both sides by sine P, right? So if we If we multiply both sides by sine p, what will happen here? Multiply this side by sine p, and we also multiply this side by sine p as well. You notice that sine p will cancel out. So what we're left back with is just 100. And that's going to equal to 109.57 times sine of p. But at this stage now, we can now divide both sides by 109.56. So we can divide this side by 109.57 and also divide this side by 109.57. By doing that, this 109.57 will cancel out this. So I'm going to continue up here. To continue right up here. So that leaves us with us sine p. So let's put sine p right here. All right. And when we divide this, when we divide 100 by 109.57, that is going to give us approximately 0.913. Then to find the angle, we need to take the inverse, right? So we know that P then is therefore going to equal to sine inverse of 0.913. So therefore, P is going to equal to, and it's just a matter of typing this on your calculator. And when you type it on your calculator, you will get approximately 66 degrees. So therefore, we are saying that angle QPR is equal to 66 degrees, and you're finished, and you will get your 15 marks for that entire question there. Now to our next question on geometry and trigonometry. The diagram below shows a circle where AC is a diameter. Where is AC? That's this line here. So we read, we will identify. So that line there is a diameter, right? So that's the line that we're talking about. Now, B and D are two other points on the circle. So where's B and D? B and D, they're on the circle. And DE is a straight line. Where's DE? Sorry, DCE is a straight line. So that's it, DCE. That's a straight line there. Angle CAB is 28, and angle DBC is 46. Calculate the value of each of the following angles. Show detailed working where necessary and give a reason to support your answer. The first question that we're asked to find is angle DBA. Let's rewrite that up here. So I want to find this angle DBA. All right, so let's look for that angle. Where is that angle? DBA, which is this angle right here. This little angle right here. That's the angle that we are interested in. All right. So how are we going to find that angle here? Now, what we can think about, we can use the information that they give us. Now, to see it much easier, we can redraw. Let's make a little sketch of this so that we don't have so much lines to deal with at once. So if we make a sketch, we can just re-sketch our circle. We're going to draw about the diameter that they give us, which is AC, all right? So this point was A, and this point is C. And we're going to, since the angle is formed at B, we're going to put back B on our diagram. And this is point B up here. So we have a line from A to B and from B to C, which gives us the triangle ABC as demonstrated here. A, B, C. But notice you have two angles forming at B. But we're looking at the big angle that forms that B that is in the triangle ABC. What is this angle? Since AC is a diameter, it shears the circle into half. So what do we know? Angle in a semicircle is equal to 90 degrees, right? So we could write this out. So remember, that's the question we're trying to answer. But this angle can help us. So we could write it out. We could say that therefore angle ABC is going to equal to 90 degrees, right? And how do we know this? The reason for this is angles in semicircle. They said that angles in semicircle has a measure of 90 degrees. So that's how we know, all right? So we're just using up the principle that we know, all right? So that's the first one. So we know. So in other words, this entire angle all the way from B all the way around has a measure of 90 degrees. But note here, the angle that they asked us to find, we have another angle over here which was given as 46 degrees, which is angle DBC. These two angles are a pair of what? Complementary angles, right? So two angles that sum to give 90 degrees, we call them complementary angles. So now we can use that to help us. So we can see that angle angle, I should have said D first, angle DBA, which is the angle that they asked us to find, is going to equal to this big angle, which is angle ABC, subtract this small angle here, which is angle DBC, right? And what is angle ABC? We just found that. That is 90 degrees minus what is angle DBC that was given. That is this angle here, which is 46 degrees. So that's 46 degrees. And what's 90 minus 46? That's just going to leave us with 44 degrees, right? And how do we know? How do we know? Always give a reason. How do we know this? We know this because we recognize that it was a pair of angle, and a pair of angle that's sum to give 90. We call them complementary angles, all right? So that's the reason there. And we will get our mark for that question, all right? So the part I know, they asked us to find angle DAC. So we need to highlight that on our diagram. DAC, right here. So they want us to find this angle here. That's the angle I want us to find. All right. It's the angle that they want us to find. So we must be clear in our head to know what we want to find. All right, so this is all the information that we have so far. How can the information that we have here help us to determine this angle? Now, you know about 8 different circular theorem rules, and I'm going to bring back this one to your memory. Angle in the same segment. We know that angles in the same segment are equal, right? So look at the segment BC. Let's highlight that segment here. So we are looking at this segment BC, all right? To be able to see what I'm going to do, it makes sense if we redraw it with less information. So let's make a sketch right here for you to easily identify what I'm going to do. So the first thing I will draw about my segment, DC, since that's what I'm going to use to determine the angle. So this is my segment, and this is D, and this is C, all right? What do I know? I have a line from C going to a point B. Let's put back that. So this is point B. I have a line going from C to B, and I also have one from D to B. What do I know? I know that angle that was given, that has a measure of 46 degrees, all right? And I also have a point over here that was given as A, and I was asked to find that angle, which is the line. I have a line from A to D and run from A to C. That's all I need, because this is the angle that they asked me to determine, DAC. When you redraw it, look at it. Angles in the same segment are equal. So therefore, if this is 46 degrees, this angle is 46 degrees. All right, so we take out some of the confusions out of it. So we could write a statement to say that angle D B C is equal to angle DAC, which is the angle we want to find, which is equal to 46 degrees, right? And then they ask us for a reason, and the reason would be angles in the same segment are equal, all right? And we get our 2 marks for that problem. Now to part C of this circular theorem question, we're asked to find angle BCE. Where is that angle? BCE, which is this angle right here. All right, that's the angle we want to find. All right, how are we going to find this angle? Do we have enough information? Not yet. We don't have enough information yet, so we will need to determine an angle. But again, we're going to redraw this diagram so that we have less line to think about. So if we redraw it, and what I want to redraw, we want the point A. These are the main points we're focusing on: A, D, C, E, and B. All right, these are the main points. So we want those points. So we need a line that starts here, that goes straight across like that. So we need, this is point D, this is point C. Let's see that out here is E. We need another line somewhere up here that represents B. So that come down like that. Clearly now we can see that this is the angle that we want to find on the outside here. And we have another point somewhere over here, which is A, all right? And we'll just connect those. And when I connect those, something should jump out at you. A, B, D, C, what is that? That is a cyclic quadrilateral. Isn't that interesting? So that is a cyclic quadrilateral. And what do we know about cyclic quadrilateral? The opposite angle sum to give 180. So what is the angle here at A? What measure is this angle? That's just 28 plus 46. So this angle at A here is equal to 28 plus 46. So we can see that angle is equal to 46 plus 28, which is going to give us 74 degrees. So this angle here is 74 degrees. So all of this angle here is 74 degrees. Which angle is opposite to it? This one down here at C. That angle there is opposite to this one. So if we find this angle, then therefore we can find the outside one that they originally asked us to find. So what statement can we write now? We can say that this is what, BCD, so we can call that angle BCD. And it doesn't matter if I say DCB or BCD, the other doesn't matter. So angle BCD is going to equal to 180 minus this angle up here, which is, let's name the angle, which is angle BAD, all right? BAD. And as you can see, it's on this diagram, but because we have so many lines, a little bit confusing, but it is easier to see it this way. So that's going to be 180 minus what? 74, right? So that's just 74 degrees. And what's 180 minus 74? 180 minus 74. That's, we take 1 from the 8, that leave us with 7. And we put it here, so 10 minus 4, that will give us 6. 7 minus 7, that will give us 0. And 1 minus nothing will give us 1. So that's 106 degrees. So we are saying that this angle here is 106 degrees. All right. And the reason for this was what? Opposite angles in cyclic quadrilateral, all right? All right, because we know that there's sum to 180, so we can subtract it from 180, and we get this. In the question, they tell us that DCE lies on a straight line, so we can use that now. Angles on a straight line measure what? Angles on a straight line measure 180 degrees. So if we know that these two angles lie on a straight line, then we can easily determine the angle that they ask us to find. So we know that angle BCE is therefore going to equal to 180 degrees minus 106 degrees, which is therefore going to give us 74 degrees. And the reason for this angle is angles in a straight line. All right, so the reason for this would be angles on a straight line, or we could say supplementary, same thing. All right. All right, so that would be the reason there, and you're finished. To part B, it says the diagram below shows a quadrilateral PQRS, where PQ and SR are parallel. PQ, so let's put on that. The arrow here signifies parallel. All right, so we can put that on just to remind ourselves that they are parallel. So PQ and RS, they are parallel. All right, and let's say SQ is equal to 8. SQ, that's it, right? Angle SPQ is 90. SPQ is 90, they give us that. and it tells us that angle SQR is equal to 82 degrees that was put on, and also angle QSR is equal to 30 degrees, all right? So everything is nice. And you can see this diagram looks on the outside, ignore the line and in the middle, that's just a trapezium, right? And you could see that this trapezium is divided into two triangles. One triangle, which is QPS, that's a right angle triangle, and also the other triangle, which is QSR, is a non-right angle triangle. So that's all the different things we can observe from this one diagram there. All right, so dealing with three different shapes in one, right? So they ask us to determine the length of PS. Where's that? PS, which is the height here. So this is the distance they want us to determine, PS. All right. What information do we have to determine the length of PS? Do we have enough information? No, we don't. This is a right angle triangle. Right now, what we know the hypotenuse, because we can see that this is the hypotenuse. We need some more angles. So what else do we know? We know this angle here, or we can determine this angle using the information that was given. Since PQ is parallel to SR, therefore you can see the Z angles here. So if this angle right here is 30, it means that this one up here is going to be 30 degrees as well. And we know that this is 30, this is 90. So therefore this angle down here is going to easily be 60 degrees, right? So we could determine that from the from just the word parallel, all right? So because QS is the transversal, as you can see there. So now we have enough information to determine what they ask us to find, which is PS. So we have two options to determine this. We can use the angle 60 degrees, or we can use the angle 30 degrees. I'm going to opt to go with 30 degrees, all right? So if we're going with 30 degrees, what are we focusing on? Really, let me just pull this from the diagram so we don't get too confused. We are just focusing on this triangle here. This right angle triangle, which is P right here, that is 90 degrees. This is Q, and this is S. We're working with this 30 degrees here for now. And we know that this is 8 centimeter, all right? And they ask us to find PS. So we can label it. So if we label it according to 30 degrees, where PS is, that's opposite, right? And opposite to the 90 degree angle where 8 is, that's the hypotenuse. All right, so we have opposite hypotenuse. All right, that sounds like a ratio that we're all familiar with, which is the sine ratio. So we know that sine theta, which is sine of some angle, is always equal to the opposite length divided by the hypotenuse length. Right? So what is theta in this case? We're using 30, so that's going to be sine of 30 degrees is equal to the opposite length, which is PS. That's what they asked us to find, over 8. And what is sine of 30? Sine of 30 is just a half. So this thing is just a half, which is equal to PS over 8. And how can we find PS? By just multiplying both sides by 8. Multiplying both sides by 8. So here you can see that 8 will cancel out 8. That leaves us with PS. So what's half of 8? That's just going to be 4. Remember your unit, centimeter. So PS is 4 centimeter. We are finished. So we find this part of it. It's just 4 centimeter. That wasn't so hard. What else did they ask us for? They asked us for the length of PQ. What is this distance now? Length of PQ. Let's label that according to 30. degrees. If we label that according to 30 degrees, that's just the adjacent side. And now we want to find the adjacent side, and we have the hypotenuse. So that sounds like the cosine of an angle. Let's remind ourselves. So the cosine of an angle, which is cosine of theta, is always going to equal to the adjacent length divided by the hypotenuse length. The angle in this case, that's just going to be cosine of 30 degrees is equal to PQ, which is what we want to find, divided by 8. All right. What's the cosine of 30? That's just going to be 0.866, which is equal to PQ over 8. Now from here, how do we determine PQ? Multiply both sides by 8 and multiply this side by 8 as well. Clearly you can see 8 will cancel out 8, so left back with PQ, right? And it's all about your calculator skills. Put this on your calculator, you will get approximately 6.928, right? So if we round this off to the nearest whole number, we will get approximately 7 centimeters to the nearest whole number, right? So this distance here is going to be 7. All right, so that's all the information that we know for now. So to part I, they asked us to determine the area of PQRS. And we recognize that PQRS was a trapezium, right? So what's the formula for a trapezium? Therefore, we know that what? The area of PQRS is going to equal to half times A plus B multiplied by the height. All right, let's look at our problem and see which part is the height. PS is going to be the height. So this is H, so that H is equal to 4. What else do we know? PQ, we can call that A, so we know that this is A. And SR, that's going to be B, all right? That's going to be B, but we don't know that length. So to find the area, we have a problem. We know what H is, we know what A is, but we don't know what B is. So we need to determine B, which is just RS, before we can think about to determine the area. So we have to divert from what they asked us to find something else. All right, so let's take a closer look at this thing now. How can we use the information that is here to determine RS? We're going to use the sine rule. So this looks like the sine rule. Every time we are given two angles and we know a side, then we can use the sine rule. How that works? We know this angle 82. We want to find this side, which we label as B. So that's one part. We know this side, which is A. So that will correspond to the angle up here at R. Do we know R? We don't know R, but we can determine it easily because we have two angles. R is going to be 180 minus the sum of these two angles, because the sum of the angles in a triangle should also add up to give 180 degrees. So first thing first, we need to find the measure of angle R. So we could write a quick statement to say angle R then is going to equal to 180 degrees minus 30 degrees plus 82 degrees. All right, so that's going to be 180 minus, what's 32? What's What's 30 plus 82? That's just going to be 112. All right. So what's 180 minus 112? That's going to leave us with 68 degrees. So we're saying that this angle here is 68 degrees. Now that we know this angle, we can now apply the sine rule. All right. So we know that the sine rule is B over sine of some angle, which is which angle now? Sine of 82. So it's going to be sine of 82 degrees is going to equal to this length, which is 8, which is going to equal to 8 over what? Over sine of 68, right? Sine of 68 degrees, right? So that's it. So we use this to solve for B, which is the unknown that we want to find there. So it's just a matter of putting it on the calculator. We'll keep this side for now. So it's going to be B over sine of 82 is going to equal to, what's 8 divided by sine? What's 8 divided by sine 68? That's going to work out to be approximately 8.63. And if we put, and if we put this on our calculator, if we put sine 82 on our calculator, then we'll have B over approximately 0.99 is equal to 8.63. Then to find B, it's just a matter of multiplying both sides by the denominator, which is 0.99, and multiplying this side by 0.99. All right. By doing that, you see that 0.99 cancel out. We're left back with B, and 8.63 times 0.99 will give us approximately 8.5. All right. And we're just going to round off this to the nearest whole number. So we're going to say B is approximately equal to 9 centimeters. So we now know this distance, which is B equal to 9 centimeters. All right. Now that we know what B is, we can now determine the area of the entire shape. So that's going to be A is equal to a half times A plus B. What's A again? That's 7. So it's going to be 7 plus 9 times the height, which is 4. All right. And now, quick calculation. What's half of 4? That's just 2. So we leave back with 2 times what's 9 plus 7? That's just going to be 16. Right? And what is 2 times 16? That's just going to leave us with 32. But remember, it's area, so it's going to be square unit. So it's going to be centimeters squared. All right? And that's how you determine the area of the shape. And that's it for these 2 questions on geometry and trigonometry. Thank you very much for watching. I hope that these two questions would have helped you to be better prepared for your upcoming CSEC exam. If you're still watching this video, it means that you are learning. So please give this video a thumbs up and share it to your friends. Thank you. To enjoy the rest of your day.